Hello everyone, welcome to the my next tutorial. It is a third part of the solar cell application. In this tutorial, we will be discuss how we can calculate energy yield with considering one of the simulation examples. In my previous video, we have seen diffuse light source and scattering interface. So before we start the tutorial, I want to introduce myself. I'm Sahil Verma, application engineer of the well-known company Impulse Technology. About the company, I have already explained in my previous video. You can visit also impulsetechnology.in for more details. Before we will be see small presentations about the energy yield calculation so we can got basic idea what we are going to calculate in the Setfos. Energy yield basically means the amount of energy actually harvested from solar panels, taking into consideration external factors like heat, dirt, and shade. Energy yield means energy produced upon total possible energy into 100. Setfos also have ability to calculate relative position of the sun and clear sky spectrum for direct and diffuse light, diffuse illumination for any given point on Earth at any time. At here, we can provide location, times, latitude, each of the angles and value at the specific dates. This enables the researcher to study and optimize their solar cell for our real-world conditions compared to simulation with fixed spectrum and illumination angles. Now I'm going to show how we can calculate these parameters. Click at here the right side and run as an administrator. About the Setfos, we have already studied about their features and how we can give inputs of our projects. It is a Setfos GUI. Who has not seen it my previous video about the Setfos, you can check out the playlist. You can got a lot of the information about the Setfos GUI. Let me give brief explanation about the Setfos GUI. For the create new simulation file, you can simply click at here. For the existing examples, you can see it here. For the save your files, as for the save as, open existing results. It is a passive optics module. It is a absorption modules. It is a drift vision modules when we want to calculate electrical parameters. It is a emission modules. It is a scattering modules. We have already spoken about our solar cell in second part about the scattering modules. It is a shift modes. We can multivariables can be shift. It is optimization and fit emission. We can extract in here our parameter. It is the examples. It is a layer structures. It is a journal tabs where we will be provide all of the inputs. You can simply click at here to show large view. We will be provide at here layer through the plus I symbols. You can add here number of the layer. You can add unlimited layer. Firstly, I will be provide air, glass, ITO, PDOT, PCBM. Through the plus I symbol, you can add more layer, aluminum. Now we need to provide at here thickness value. For the glass, it will be 10, ITO 120, PDOT it will be 110. For P3ST PCBM as active layer, it will be 100. Aluminum, it can be same. Top and bottom layer are semi-infinite medium, so thickness are irrelevant at here. Now we need to import at here the refractive index file, which is wavelength dependent layer. For the glass, it will be 1.5. Glass, it is an incoherence layer. ITO, we need to import at here .nk refractive index files at here supported .nk file format. You can simply click at here and imports your files. Similarly for the PDOT, one by one, you need to import your refractive index files. pay.al4083.nk files for the P3ST PCBM and aluminum. At here, layer structures are completed. You can see at here your layer structures is totally depend on the thickness value. According to this, they change. Now we need to activate absorption modules. You can see at here single wavelength or energy. It is a ranges. It can be same and it is totally depend on you which value you want to consider. 380 to 780. As we discussed, clear sky spectrum, so we can provide at here the location and times. You can see that here diffuse light is only considered in scattering modes. I have already told about the Setfos GUI that you can see in similar location, date and time, or module orientation and weather. Which date you want to consider, you can simply choose at here. It is a latitude, longitude and elevation. For the time zone, you can see and tilt and azimuth and what is the weather conditions. Latitude and longitude, it will be same. For the elevation, you can consider 439. Date and times, it totally depend on you which value you want to consider. If you want to change at here, you can simply change. It is a time zone. At here you can see positive numbers indicate the zone to the east and negative ones to zone to the west. It is a time. At here tilt, it will be 45. It totally depends on your project which value you want to consider. Once again I am telling you, azimuth it will be 180. Cloud cover it can be 0. At here Setfos are able to calculate the relative position of the sun and clear sky spectrum for direct and at here diffuse light illumination for any given point on earth at any times you can see. This enable researchers to study and optimize their solar cell for more real world condition compared to simulation with fixed spectrum and illumination angle. Now you can got a lot of the hints how you can provide date and times and module orientation whether we are considering at here same as a tutorial, so you can got exact graphs and you can easily understand what I want to say in here. As same as the tutorial, it will be 14 July, 15, 30, it will be same. You can see at here the diffuse spectrum sweep range. When we activate the sweeping modes at here, when sweeping over the parameter date and time set for compute for each sweep point the time and location dependent incident sun spectrum. Run a simulation for corresponding light incident angle and post-process the sweep point to obtain overall energy generated by solar cell over the time steps. You can simply select at here date time. Shift it will be same as tutorial. 19 June 13:30. It will be same time. You can simply edit like these also. It will be same. Give interval and hour. At here name energy yield calculations. calculation. Click at here play button. You can see at here energy yield value. You can see their graph for the direct spectrum and diffuse spectrum. It is a cumulative energy yield course for simulated days. You can see 20 June, 21 June, generated power. It is a incident intensity as similar as tutorial can be say incident power for direct and diffuse parts, illumination, solar angles, photocurrents, graph are given, stat contribution, photocurrent. At here passive optic properties are given. You can see one by one like this. Absorption. If you click at here play button, with the time variation you can see how they are changes. If you click for the date and times, and now you can play similar like this. Layer absorption, reflectance, stack contribution and transmittance. For the polarization transmittance, for the S polarization. I hope you got a lot of the information about how we can calculate energy yield. Now I'm going to end at here my tutorial. If you have any query related to this, you can ask in comment box. In the description box, email are also given, and you can visit impulsetechnology.in website. Who has not seen it my previous video, please check out the playlist. And who want to book our demo and want evolution license, you can contact us in the impulsetechnology.in. Thank you very much.